Okay, everyone, so let's look at another optimization problem. So the question reads that a window of fixed perimeter of 8 meters consists of a rectangle surmounted by a semicircle. So now you know that you have two shapes. And so it's asking you, what is the ratio of height to radius that will admit the most sunlight? So immediately you know that you're working with a perimeter, and because there's a sunlight and the sunlight goes through the window, this here, you're working with an area, okay? So the first thing you want to do is draw your shape. And then second, you want to draw out your equations and your functions. And then you want to determine your constraints and work from there. Okay, so let's draw out the shape really quickly. So that's a rectangle. Okay. Normally that would just be length times width. But we have a semicircle, right? Right along the top there, we have a semicircle. And so this side here, this would be a radius, okay? And so you should really try to write things, everything in terms of the same variables. So if they're asking for height and radius, just write things in terms of height and radius. So we can assume that this here is the height of the rectangle, and that's the radius of the circle, right? So in this case, your width is just going to be 2 times your radius, and your length is just equal to your height. So let's start by writing the perimeter equation, okay? So we know that perimeter is the summation of all your sides. So in this case, you have the 3 sides of your rectangle, and then the half of the length of your, half of your circle, okay? So let's do that together. So in this case, it'll be so we have a height here, so h plus 2r from the bottom of the rectangle plus another h, the other side of the rectangle, and then it's surrounded at the top by a circle. And you know that the circumference of a circle is 2 pi r, but in this case it's only half, right? So the 2's cancel, so it's just pi r, so plus pi r. So in other words, we can rewrite this as 2h plus 2r plus pi r, right? Now, we immediately know that everything should be in terms of h and r, so we might as well write your h in terms of your r, right? So why don't we rearrange that? So it'll be 2h is equal to 8 y8, because this is all equal to 8, right? It's given us 8. So 2h is equal to 8 minus 2r minus pi r, right? So if you were to write just h, it's going to be 8 all over 2, okay? And you can simplify that further. It's going to be 4 minus 2 plus pi into r all over 2. Okay, so now we have h. And as you've seen in other examples, we've done this before, where you rearrange your equation in terms of your other variable, so that when you come to take the derivative, everything is in terms of one variable. So in this case, speaking of derivatives, you're going to have to take the derivative of your area. Why? Because the question here asks you about the most sunlight. And you know that sunlight goes through the area, as we spoke about. So you want to maximize, you want to optimize your area function, okay? So let's write the area equation. It's going to be the area of your rectangle plus the area of your semicircle. So in this case, your length times width, so it's h times into 2r, right? That's the area of a rectangle, plus, you know that the area of a circle is pi r squared, but in this case, it's half. So it's half pi r squared. So we already know what h is, right? We just solved it right here. So we can really just substitute that in right now. So if we do 4 minus 2 plus pi over r into 2, 2r into 2r plus pi r squared over 2, and then eventually that's going to look something like this: half pi r squared plus 8r minus 2 plus pi r squared. Okay, so now we are in a position to take the derivative. Okay, so let's do that on the next page. Okay, so let's take the derivative of a, right? So I'll write that here. So a primed is going to be equal to, switch back to white, a primed is going to be equal to, remember what we said, you're going to take your exponent, you're going to multiply it by your constant, and then you're going to subtract by 1. Okay, so in this case, it's just going to be your 2 into your half is just 1, and then you're going to be left with pi r plus 8, right? Because 1 times 8 is 8, and then 1 minus 1 is 0, so the r goes away, minus 2 into 2 plus pi r. Great, now we have our first derivative. Now we can set that to 0, and then solve for r. So let's do that now. So if we have pi r plus 8 minus 2 into 2 plus pi into r equal to 0, then we can do this. We can take that over, so it'll be 2 into 2 plus pi r minus pi, right? We're equating everything to 8. And eventually you're going to end up with 8 is equal to 4 plus pi r. And then r is going to be equal to 8 over 4 plus pi. Now I skipped a bunch of steps here because this is just simplification. If you're having problems doing that, then just post in the comments and we'll make sure to explain that to you guys in detail. Okay, so now we have r, and over here we've already determined h, right? So we can substitute r back into the h equation to find out what h is. So let's do that together. So h is equal to 4 minus 2 plus pi over 2 into 8 over 4 plus pi. Okay? So once you simplify all this, it's actually not so hard to do. Once you simplify all this, I'll do a very quick step here with you guys. So it'll be 2 plus pi. Remember that 2 goes into 8 4 times, so that is going to be multiplied by 4. And then that'll be all over 4 plus pi. And then you can expand that out, and your 4, you're going to multiply by 4 plus pi, right? Because you want everything to be consistent with the same denominator. You're going to end up with 8 is equal to 4 plus pi. So you're noticing something right away, right? Your h and your r are actually the same. So when the question asks what is your equation of h over r, it's actually just 1, which means that your h, your height of your rectangle and the radius of your semicircle should be the same in order to maximize the amount of sunlight. But is it true that what we found here is the most sunlight? So how do we know if it's the most? You have to take the second derivative, right? So let's do that together. So if we know that a primed of r is equal to pi r plus 8 minus 2 into 2 plus pi over r, your a double primed of r is just going to be pi, right? 1 times pi is pi, and then 1 minus 1 is 0. So your r goes away, your 8 goes away, this 8 goes away, your r goes away, and then you're just left with minus 2 into 2 plus pi. And then if you expand that out, you're going to have minus 4 minus 2 pi. And then basically, it's just going to be minus pi minus 4. And so this shows that it is in fact less than 0. And we know that when your function, whatever the function may be, that's a general, so your function f of x double primed when it is less than 0, your value is always a maximum. So in this case, we did find that that is the maximum amount of sunlight coming in if your h and your r, your ratio is equal to 1. Hope that helps.